Okay, so y equals tangent of x and y equals 2 sine of x. Okay, so let me just draw a rough picture of a tangent of x. Okay, so roughly it looks like that. All right, it's got a minus pi over 2 and pi over 2 as asymptote. And y equals 2 sine of x. Okay, so this is pi over 2 and this is pi. Okay, that's what it's going to look like, where that right there is 2. Okay. Of course, on the other side, it's going to look similar. Okay, so again, you can see that it's symmetric. Okay, it's symmetric about the origin. Okay, so really all we have to do is find this area. Okay, this area here, and double that. Okay. Now, so what's the intersection point? Let's find the intersection point. So let's make the tangent of x equal to 2 sine of x. You get this. Okay, so let's cross multiply. So you get sine of x is equal to 2 sine x cosine of x. Okay, and let's bring this to the other side. So you get 2 sine of x cosine of x minus sine of x. Factor out sine of x. You get 2 cosine of x minus 1 is equal to 0. Now keep in mind that we're actually solving for this so that any cosine of x actually cannot equal to 0. Okay, from here, how can you have 0, right? The whole thing being 0. There's two ways. Sine of x equals 0, which is going to give us x values such as 0, pi, 2 pi, minus 2 pi, and so on. But really interested in 0 because everything else is out of the range when we're talking about only from minus pi over 3 to pi over 3. Okay, 2 cosine of x minus 1 is equal to 0, which means cosine of x is equal to half. Okay, cosine of x is equal to half when x is equal to pi over 3 actually. Okay, so this must be, where they intersect must be pi over 3. And the question actually told us to only look at from minus pi over 2 to pi over 3. So we know exactly what we have to integrate. We're going to integrate from 0 to pi over 3. Okay, in that region, the sine is right on top. Okay, so it's actually 2 sine of x, and the tangent is below, so minus tangent of x. Okay, so if we double that, that's the area. Okay, because there's one right here too. Okay, so integration of that, that's going to be minus 2 cosine of x. Okay. Okay, so let me put that here, 0 pi over 3. Okay, and then we have a minus 2 integral of tangent of x dx, 0 to pi over 3. Okay, so tangent of x is actually integration by substitution. Okay, so tangent of x is sine x over cosine of x dx. If you let cosine of x equal to u, you get minus sine of x equal to du. Sine x dx is equal to du. So sine x dx equals minus du. Okay, so this is going to equal to minus, right, minus du over u, which is minus ln of absolute value of u. Okay, which is same as minus u to the power of negative 1 if you use log law. So this is going to give us ln of 1 over cosine of u, cosine of x, which is the same as ln of secant x. Okay, secant x. So this one actually, I derived the whole thing here, but I highly recommend you memorize that because you just want to know, like, this is one of the most popular trig, right? After sine and cosine is the popular trig ratio. You want to know the antiderivative right away without having to derive it every single time, especially during a test time. Okay, so this is going to be 2 ln of secant of x. Okay, and we're going to plug in pi over 3 and 0 in there. So, okay, plug in pi over 3 and it's half. Plug in 0, you actually get 1. Okay, ln of secant of pi over 3 is going to give you actually 2. Okay, so it's ln of 2 and ln of 1. Okay, ln of 1 is going to be 0. So we have minus 4 times by minus half. In here, ln of 2 minus 0, so that's it. So it's going to be 2 minus 2 times ln of 2. That's the answer. Okay.